right, so we're here to do an inspection of the FRC Robotics Ri3D robot. Before we get started, though, I want to point everyone to the Q&A and the team updates. This inspection is happening in week 1, which means that there will be a dozen or so team updates before we even get to the first week of competition. And those team updates can change any of the rules we talk about tonight. So please do not take any of these rules as fully writ. Check the rule book, check the team updates, and check the Q&A to make sure that you are fully up to date before you get to your competition. Hey guys, we'll start here with the sizing box. I want to rotate your robot so it fits. Now what we're looking here is to make sure that the robot fits in the full 28 by 33 dimensions. So in this case, we have a taped out outline on the floor. At your event, it could be a taped outline. They may use tape measures. They may use a wooden box to actually check your size. We generally try to eyeball it unless it's really super close. In this case, I think things are good enough. We'll check the height here with the tape measure. Make sure that they're within the 55 inches. They are well within 55 inches, under 54 it looks like. So now that we know that the size of the robot is okay, we move it over onto the scale to check it. I think we need to turn it on first. All right. Now the weight, like normal, is 120 pounds, and you guys forgot to take out your battery, so you are overweight right now. Take out the battery. We weigh the robot with the bumpers off and the battery out. Neither of those count towards the robot weight. So now they are at 110 pounds, which makes them perfectly fine. We take the robot off and we grab the bumpers and we throw them on the scale. The bumpers have a separate weight limit, 20 pounds, so we have to weigh those separately. By weighing them separately and weighing the robot, when we do our re-inspection, we can weigh both the robot with the bumpers on and you don't have to take them off again. Makes it a little bit easier for you before we go into eliminations. All right, bumpers here are 9.5. So the total robot weight would be 119.5, adding the two together. At this point, the team would go back to their pit and put their bumpers on. All right, now that we are back in the team's pit and they've put on their bumpers, as you can see here, we start by actually inspecting the bumpers themselves. Standard bumpers have a whole bunch of rules associated with them, most of which you need a tape measure to verify. So we start by looking at the 6-inch rule. The bumpers have to extend 6 inches in from every corner of the robot. So to measure that, you measure right here in 6 inches. Make sure your bumper has full coverage. And we go over, check the other side. And this one is right on the money. Very close. Bumpers do have to be securely mounted. As you can see, this is not securely mounted. So the team, in this case, would be asked to go back and fix this and get this secured better so that it's not flopping around. It's not going to get ripped off, or if you should pick up the robot by this bumper, the robot's not going to fall on you. Once we look at the 6 inches from each corner, which obviously the 2 back corners are good with, we look at the bumper height. This year, the bumpers have to be between the ground and 7 inches off the floor. So we can check that, and because of the wobble in this one, it's getting a little high in places. So this bumper really does need a lot of work on it. These ones on the side here look okay. Check all the way around the robot. And they're all really either right at the limit or, as this case in the front bumper again, too high. So a little work on the bumpers to get them mounted properly. Now, normal bumpers on your robot will not have your team name on them. Instead, they will have your team number. It has to be white or outlined in white. Certain dimensions, just like you see here on the 4607 robot. This would be considered a legal bumper number. You can check the stroke width against the rules, the number height against the rules. You have to have your team number on all 4 sides of your robot, so it's visible from every side of the robot. And the only items you're allowed on your bumper are the team number and, if you wish, the first logo. The next section of the rules we're going to be looking at is the mechanical section. This includes basically all the mechanical aspects of the robot. In particular, first off, we want to look at the 16 inches from the frame perimeter rule. Your mechanisms can only extend up to 16 inches, which in this robot is your intake. So for this, we would measure out from here out to 16 inches. And obviously, there's no problem with this robot, regardless of what motion these arms go through. That's probably true for most elevator-style robots. However, arm-style robots are another story. Those we expect to be very close to that 16-inch limit, especially when they get up to a right angle. Make sure that if you're designing an arm, that it is within your 16 inches through the entire range of motion for the arm. Next up, we want to look at sharp edges or protrusions that pose a hazard for participants, robots, the arena, or the field. So, for example, these arms here form a leading edge of the robot. In this case, it's a rather large leading edge. We want to make sure that there isn't any risk of spearing or entangling with other robots, which this would be considered a pretty normal large surface area, so that's a minimal risk. In terms of looking at sharp edges, we're primarily looking for things that are going to damage individuals and damage game pieces. So we know the game pieces come in to this area here, so we're going to check over all of these surfaces to make sure that there aren't sharp edges that may rip the fabric of the game piece covering. In terms of safety for the participants, we want to find the main circuit breaker, which is, I'm sure, on here someplace.
Right here.
Over here. And we want to make sure that there are no sharp edges around that main circuit breaker that may injure someone when they go to turn the robot on or off. A lot of breakers may not be quite this accessible. They may have a hole that you have to reach through. Make sure you very cleanly deburr that hole so that you can get your fingers in there and turn it on and off easily and safely. Next up, we want to look for any prohibited materials. This would be things like sounds, lasers, noxious or toxic gases, inhalable particles of chemicals, lubricants that may end up on the floor, things of that nature. Do you have any of that on your robot?
No, the only thing we have is open gearboxes.
Yep. So open style gearbox here is very common. You do want to make sure that you lubricate your gearboxes and run those in. And by running those in, you'll get all of that loose lubricant out before you get to competition, and you won't mess up the field carpet. Next, we want to look for unsafe energy storage devices. Obviously, the battery is a big energy storage device, but for this, we're primarily looking at springs. In this case, the robot has, very obviously, 2 springs here. Now, these springs aren't going to be under a huge tension load under normal operation. However, when we see springs, we like to make sure that nothing's going to cause them to explode. Obviously, these springs are in a place where they will be hit by the game pieces repeatedly, and for safety reasons, it would be nice to have a cable that runs through the spring to help contain any pieces should the spring decide to shatter at some point during the competition. We want to look for risk of damage to other robots or the field. So, like we already mentioned, spearing here on the front edge, entanglement hazards, not really much. We may consider this to be a little bit of an entanglement hazard. If someone comes by and sweeps this and grabs it, then you're in a world of hurt as a robot. And we may have some recommendations for you to help mitigate that problem so that you don't encounter that on the field. When we look for a risk of damage to the field, primarily we're looking at what interacts with the carpet itself. The field volunteers absolutely hate having to patch the carpet because it gets ripped up, so we want to make sure that there aren't any sharp edges, any protrusions, anything that's going to grab that carpet and rip a big hole in it. So we look down at the wheels, we look at surfaces that are close to the carpet. Make sure that there aren't any sharp edges, any protruding bolts, anything of that nature that's going to cause an issue with the carpet. Decorations. None of your decorations can interfere with other robots. In the past, this has primarily been centered around the vision targets, which have been done with retroreflective tape. I think that's less of an issue this year. But you want to be careful that you don't have any, red and blue lights up near the top that may be mistaken by a vision target, by a camera for a robot as a vision target on one of the scales. Next, we will ask for the CAW, the cost accounting worksheet, which, because you're an Ri3D team, you probably don't have yet. You want to make sure that you make your CAW as you're going along. It's really a great place to include the weight of components and make sure that you're going to stay within your weight budget. And if you do it as you go along, then you don't have to try and figure out what's on the robot while it's staying in the bag. So make sure you get your CAW done early and update it quite often. Are there any servos on the robot?
Not that I know of.
No servos. If there were servos, really the only limit on servos this year is that they cannot cost more than $75. So if you do use a servo, make sure that you have the product page or something that shows how much that servo actually costs for the sake of passing. And in fact, the servo should be on your cost, so you should have the price right there. At the end game, we have to be able to verify that game pieces can be removed from the robot without powering the robot on. So, we'll grab a game piece, we'll stick it in, you can pull it out, and we will know that, indeed, it can be removed without turning the robot on. Quite simple. The robot also has to be able to be removed from the field at the end of the game. So, if you're climbing, like with the climbing mechanism here, you have to be able to remove the robot without turning it back on. Okay, the next section is the electrical section. First up, no electrical components can be modified. Except for motor mounting and output shaft, motor wires can be trimmed, the locking pins on window motors can be removed, connectors on automotive motors may be modified, and certain devices may be repaired with parts identical to the original, including the PDP fuses. Servos may be modified per manufacturer's instructions. There are several rules that list the legal modifications, but in short, don't modify your electrical components. It makes them safer and easier. And I'm assuming you guys haven't modified any of the components.
No, we have not.
All right, the battery. One robot battery. Looks like this. Make sure it looks like this. And you won't have any problems. You want to make sure that your terminals here are fully insulated. And when we look at this, we will look at all of the batteries you brought with you. We'll make sure that all of them are fully insulated. And that all of them are secure. A wiggling battery terminal can cause issues for your team in terms of browning out and lost communications. So be very careful with that. We also look at how the battery is mounted inside the robot. In this case, I would say this is not securely mounted. If you look, I can very easily lift the battery up, and it's going to pop. At some point, the robot's going to take a hit, and this battery is going to pop out. When it pops out, you now have a 13 or 14 pound battery bouncing around inside of your robot. A lot of delicate electrical components are near it, and should it bounce around enough, it's going to unplug itself, and your robot's going to sit dead on the field for the rest of the match. You don't want that to happen. Make sure that your battery is securely mounted so that it pretty much can't move while it's inside the robot. Visibility. We have to be able to actually see the main breaker, including, or the PDP, including all of the breakers during the inspection process. It doesn't mean that they have to be visible on the field, but we have to be able to see it and read those values during inspection so that we can verify that all of the wires are the correct gauge. The main breaker has to be accessible. Obviously, we just looked at that over on the other side, and it is very accessible. Robot radio. You can have one of the open mesh radios, right? Both of them, I believe, are legal again this year, the AN and the AC. you will have to program this radio at competition, at every competition you go to. And the radio has to be powered from your VRM right here, and that VRM has to be powered from the dedicated terminals here on the end of your PDP. The robo-reel power cord, this one right here, has to be powered from the dedicated terminals on the end of the PDP. Very straightforward. Those are the only two items that have to be powered from those dedicated terminals. Everything else can be powered right here from the side. You do have the option, if you have pneumatics, to also include your PCM on this dedicated terminal as well. Wire size. This is typically one of the hardest items to verify on the robot because it's hard to get to the wires themselves. We need to be able to verify that your wires are all the correct size. So for 40 amp breakers, it has to be 12 gauge or better. And so, I don't know if you can see it on the video, but there is writing on here. And if we get in real close, yep. So I could see on one of these wires right in here that it says 12 gauge on it. So that's for all of these 40 amp breakers. They all have to have 12 gauge wire coming off of them. We look both the wire that comes out here to the speed controller and leaving the speed controller coming down all the way to your motors. For your 20 amp breaker here, this is minimum of 18 gauge wire. So it can be actually smaller wire, which in this case, this looks like this is the wire that actually came with that custom circuit, which inherently makes it legal for that custom circuit. Wire colors must be color-coded properly. So there's standard conventions here: red, white, brown, yellow, or black with a stripe for your positive supply wires, and black or blue for your return wires. In this case, you can see that they used red and black for all of their wires. And that applies only to your constant polarity wires, basically anything coming out of the PDP. You can only have one wire per Wago connector in here. So you cannot, say, power two spikes or two sparks here from one terminal. You have to have only one wire going in each of those. When it comes to custom circuits and a few other things like LEDs, you can power multiple items from one terminal, but you can only have one wire coming in here. And then it has to branch out further on. Motors. This year, there is actually no limit on quantity for any of the legal motors, which is pretty nice. So we just have to go through and look at all of the motors. In this case, looks like there are some SIMs on your drivetrain, right? There's a 775 Pro, one of the new Andy Mark 775s there, and two more 775 Pros. And I think that's it, right? So there's only those 4, 5, 6, 7, 8 motors total. We can look and you see the 8 speed controllers. We will verify that those 8 speed controllers are going to the motors that they're supposed to go to, so that you have each speed controller controlling its own motor. There is, we do want to look at table 8-2 in the rules. It's right by R36. That tells you how many motors you can control per speed controller depending on the type of motor it is. The motors and actuator control have to be controlled by these legal speed controllers. In this case, Talons and Sparks. Both are legal speed controllers. There's a whole long list of legal speed controllers. Make sure you check it out. There's a lot on there. We aren't going to go through all of them here today. Custom circuits. In this case, they do have custom circuits on this robot. This little guy right here is an LED controller. So that's considered a custom circuit. It's not actually hooked up to much right now, but you can see we do have some LEDs going down here, cables coming out, and powering some LEDs underneath the chassis. So we want to look carefully at those LEDs and those custom circuits to make sure nothing's getting shorted out, that we have proper wire gauge all over. We also need to verify that custom circuits are not modifying the control pathways for any of your motion components, like motors or pneumatics. Next up is branch circuit. Each branch circuit is protected by one and only one breaker. So when we are looking at our circuit breakers here, we are looking to make sure that you don't have, for example, one speed controller that branches out and goes into 2 different circuit breakers. We need to make sure that you only have one circuit breaker going to each component. In this case, 8 speed controllers with 8 breakers, and then 1 breaker here for the LEDs. Makes sense? It's probably wired up correctly there. Were this robot to have pneumatics on this, we would make sure that the pneumatic control module is connected to the RoboRio through the CAN bus, which is right here. Since they don't have it, they don't have the PCM on here, but you can see the CAN is connected going all the way down here and right here into the PDP. That is a required CAN connection. Next up is isolated frame. We need to make sure that the frame is electrically isolated from the robot control system. To do that, you get a multimeter set to your resistance, unplug the battery, turn on the breaker, and then we measure between the battery terminals and the frame. And you should see a very high resistance. In this case, it's infinite. So we don't have to worry about any electrical isolation. Obviously, they properly have everything isolated. The key points we find these days to look at if you have an isolation problem would be custom circuits like LEDs, especially those LED ring lights that many teams use have a tendency to short out against the frame because they have exposed contacts on the back. Next up, terminals. Each terminal on the battery must be fully isolated. We already looked at that. And the PDP CAN bus. That covers everything with electrical. So this robot doesn't have any pneumatics. So we skip the pneumatic section and we go straight to the power on check. For the power on check, the first thing we look at is the driver station. We want to make sure that there's no unauthorized wireless communication involved with the robot or the driver station. With the robot, we've already looked at the entire electrical system, so we know there are there's no unauthorized wireless there. The driver station in this case is a laptop and a couple of controllers. There's no unauthorized wireless happening here. If you have pneumatics, we would confirm the pneumatics operation now, but there's no pneumatics, so we're not going to do that. We need to check the robot signal light. You can have up to 2 of these lights. That should be secured a little bit better there on your robot. And in this case, yep, you can see on the bottom side here, they have a jumper in place, which is required to make the light blink in the proper pattern. On the driver station itself, there are a couple of items we want to look at. First, we check the team number, make sure that that's the correct team number, which I assume you guys are using the 4607 team number. Here, we need to check some of the firmware versions, which is listed on this tab here. You can see firmware versions listed right here. Specifically, ones I want to call out, the driver station has to be version 18.0 or newer. So you can see this one, 17.01, has not yet been updated for this season. The RoboRio has to be up to FRC 2018 V16. So you can see 2018 V16. That is the correct version for the RoboRio at this time. Both of these version numbers may, and if the past is any indication, probably will change before we get to competition. Other versions you'll want to pay attention to are anything on the CAN bus, the PCM, your Talons, any of the other speed controllers that can go on your CAN bus. Those will have software versions as well. You'll want to make sure that you have those on the correct versions and updated so that they work properly for you without any issues. Once we do that, we do a power off test. In this case, we are powering off the robot and making sure that all the LEDs turn off. And if you had pneumatics at this point, we would release any stored air pressure to make sure that all of the air pressure and releases from the system and everything moves freely at the end. Finally, we look at the size of the driver console. It can be 60 inches by 14 inches deep and up to 6 feet above the floor. In this case, it's obviously relatively small. There's no issue there. Once we finish the power on check, and assuming the team has actually passed inspection, a team captain and a team mentor will sign the back bottom of the inspection checklist. This checklist will be released about a week before we bag up the robots, just in time for you guys to download it and run through it yourselves and make sure that your robot is completely legal.